keeping production facilities running at all times, 24 hours a day, 365 days a year, avoiding expensive breakdowns, improving the reliability of installations. Industry is constantly dealing with these issues. To keep plants operational at all times, many industries have established predictive maintenance programs. One of the most valuable diagnostic tools for any predictive maintenance program is thermal imaging. FLIR Systems cameras contain all the features needed for quick and powerful thermal inspections. Electrical cabinets and motor control centers are regularly scanned with a thermal imaging camera. If left unchecked, heat can rise to a point that connections melt and break down. As a result, fires may break out. Besides loose connections, electrical systems suffer from load imbalances, corrosion, and increases in impedance to current. Thermal inspections can quickly locate hotspots, determine the severity of the problem, and help establish the time frame in which the equipment should be repaired. One of the many advantages of thermal imaging is the ability to perform inspections while electrical systems are under load. Since thermal imaging is a non-contact diagnostic method, a thermographer can quickly scan a particular piece of equipment from a safe distance, leave the hazardous area, return to his office, and analyze the data without ever putting himself in harm's way. FLIR Systems thermal imaging cameras are perfectly suited for electrical inspections. They're highly portable, ergonomically designed cameras ready to be used several hours per day. FLIR cameras deliver crisp, high-resolution thermal images that will register temperature differences as small as 0.03 degrees Celsius. They contain all the necessary features to make well-informed decisions. Useful features include a touch screen, scalable picture-in-picture, which makes it easy to locate areas of interest, thermal fusion, which merges visual and thermal images to offer better analysis. Most FLIR thermal imaging cameras are also equipped with meter-link technology. FLIR meter-link technology simplifies the work in electrical inspections by making it possible to transfer, via Bluetooth, the data acquired by an X-Tech clamp meter into the thermal imaging camera. The meter-link technology saves time and eliminates the risk of erroneous records or notes. The ability to save both a thermal and visual image allows showing the location of the hotspot to the people who will be making the repairs. Also, distribution transformers benefit from the use of thermal imaging. Examples of failures in low and middle voltage equipment are high resistance connections, corroded connections, internal fuse damage, internal circuit breaker faults, and poor connections and internal damage. Thermal imaging cameras are also commonly used for electrical high voltage inspections. As electrical connections become loose, there's a resistance to current that can cause an increase in temperature. This can then cause components to fail, resulting in unplanned outages and injuries. In addition, the efficiency of an electrical grid becomes low prior to failure. Thus, energy is spent generating heat, causing unnecessary losses. Power transformers are often checked with thermal imaging cameras. Temperatures of the cooling fins and the high voltage connections can be compared so that, if necessary, corrective action can be taken before real problems occur. Also, high voltage power lines can be inspected with a thermal imaging camera. Other high voltage installations that are checked with a thermal imaging camera include circuit breakers and switches. Potential problem areas will clearly be shown on the thermal image. Examples of failures in high-voltage installations are oxidation of high-voltage switches, overheated connections, incorrectly secured connections, insulator defects. In many industries, mechanical systems serve as the backbone of operations. Thermal data can be an invaluable source of complementary information to vibration studies in mechanical equipment monitoring. Mechanical systems will heat up if there's a misalignment at some point in the system. Thanks to features such as line profiles, you will immediately see if there's a problem. Conveyor belts are another example of moving parts. If a roller is worn out, it will clearly show in the thermal image so that it can be replaced. Typically, when mechanical components become worn and less efficient, the heat emitted will increase. Consequently, the temperature of faulty equipment or systems will increase rapidly before failure. Motors are also widely inspected with thermal imaging cameras. Motors can be observed for brush contact wear and armature shorts, both of which typically produce excess heat, but not necessarily vibration, prior to failure. Thermal imaging gives a full overview and allows to compare the temperature of different motors. When necessary, further examination of the overheating motor can be done. Most FLIR cameras are equipped with a laser pointer which eliminates the tendency to finger point in dangerous areas. Examples of faults that can be detected with thermal imaging are overheated motors, suspect rollers, overloaded pumps, overheated motor axles, hot bearings. Thermal imaging also gives valuable information about the condition of pipe, tube and valve insulation. A thermal imaging camera can quickly give an overview of the entire installation. There's no need to check each pipe individually. Thanks to analysis tools like spot meters, line profiles, areas, isotherms, and many more, potential problem areas will be clearly identified, and the repairs can be done before real and sometimes dangerous problems occur. FLIR thermal imaging cameras are also used to inspect ovens and drying installations. Thermal imaging cameras are also used in the petrochemical sector. They provide rapid, accurate diagnosis for furnace maintenance, refractory loss management, and condenser fin diagnosis. Heat exchangers are checked to detect blocked pipes. FLIR Systems thermal imaging cameras are also widely used for inspecting cracker installations. Many pipes and tubes in a cracker are insulated with heat-resistant refractory stone. Thermal imaging can easily see if the insulation is still intact. Steam traps are also subject to thermal inspections. potential problems will clearly show up in the thermal image. Other examples are insulation breakdowns, hot spots in ovens, refractory insulation defects, damaged insulation, and breakdown of refractory on rotary cement kilns. During certain production processes, gases are generated which are burned off in flares. The flames generated can be invisible to the human eye. It's important to be sure that the flare is burning, otherwise harmful gases might enter the atmosphere. Thermal imaging can easily see if the flare is burning or not. Thermal imaging can also easily be used for tank level detection. Thanks to emissivity effects or to temperature differences, the thermal image clearly shows the level of the liquid. Thermal imaging can also easily be used to see if all barrels in a production process are properly filled. Thermal imaging is used in numerous industries. Other applications include finding hotspots in welding robots, inspection of aeronautical material, mold inspection, checking temperature distribution in asphalt pavements, inspection in paper mills. Whether you're interested in inspecting electrical installations, mechanical equipment, refractory, pipework or high-temperature equipment, flare and tank level detection, and many, many more, thermal imaging is the perfect tool for predictive maintenance inspections. FLIR Systems offers you the perfect solution for the most demanding predictive maintenance applications. From the extremely affordable FLIR i3 to the full-featured P-Series, FLIR Systems offers you a full product range so that you can choose the thermal imaging camera that best fits your needs. Contact FLIR Systems and find out what thermal imaging can do for you in your facility today.